Hello and welcome back. This is A-level math S1, and today we're going to start with chapter 1, which is permutation and combination. And so let's get right into it. And we are going to understand this, and then we're going to do all these questions. It's broken down into four parts: the digits. We have a question of the digits. Then we will have a question of the anagrams. We'll do all these questions. Then the gap rule and the people. Okay, so we have lots of questions, and now let's begin. What is combination? What is combination and permutation? So let's start with combination. A combination is making a selection of object where the order of the object does not matter. For example, if you have five coats, you know, of different colors, red, blue, brown, green, and it's been lying on a bed, five coats, and you want to choose any two coats from any five, so then you will do 5C2, and you will get the possibilities as that what are the maximum possibilities to take any two codes out of five. So this is the example of combination. Okay, you are making a selection and you are trying to find the possibility that that in which way I can get those two clothes out of five. Okay, so if I'm using if I just use a calculator, if I put 5C2, then it would be 10, which means there are 10 ways to take two codes out of 5. Okay, similarly, if for example there are 5 pants and I want to take any one pant from it, what are in how many ways can I take one pant out of 5 pants? So I will do 5C1 and you will get 5, which means there are 5 ways. Obviously this is the most simplest example which I have just given you, right? Taking any, there are obviously 5 ways because I'm only taking one pant out of 5, right? Okay, so this is combination. Combination is any selection of objects where the order of the object does not matter. Always unique solution, no repetitions, and so this is NCR is equal to n factorial upon r factorial multiplied by n minus r factorial. Okay, so n factorial is the total number of objects, and r is a selected number of objects from the total multiplied by n minus r factorial. Or you can just use it directly in a calculator. It doesn't really matter. You don't need to memorize this, but still, for example, if you want to just do it without a calculator, go for it. Okay, factorial is used for arrangement. It will be definitely be used in permutation. So whenever you have been seeing this like 5 factorial, 3 factorial, it means that there are 3 objects A, B, C, and you want to make some you want to know the possible arrangement of these objects. Like the possible arrangement could be B, A, C, or C, A, B. Okay, so this is the example of making arrangement. So I could just do it directly. 3 factorial. 3 factorial will be 3 multiplied by 2 multiplied by 1, which means 6 ways you can make an arrangement from these 3 letters. This is how you do it. Okay, this is how you make the this is how you do the this is how you arrange the objects, and the order really matters in factorial and permutation. In combination, the order does not matter. That's one thing that you need to understand, the difference between permutation and combination. And the factorial comes in permutation because permutation is NPI is equals to NCR multiplied by R factorial. So permutation, the combination is part of permutation. Permutation means making an arrangement of objects in definite order, and order really matters. Which means after making a selection, like for example, if there are 5 codes and you are taking 2 codes from it, making you need to know how many ways I can take 2 codes out of 5. Then I will do combination, and after taking these 2 codes, I want to know that in how many ways I can make an arrangement of these 2 codes, right? So I will just do it multiply by 2 factorial, which means there are 2 ways to arrange these 2 codes, left to right, right to left. Then you can just do it step by step. Like for example, you can just make a selection and then arrange it, or you can just do it directly and PR in a calculator. It's up to you. But I would prefer to do it not directly, because it really helps to solve the question with logic, and doing step by step will make it easier for you and for me. Okay, so this is combination permutation. There's nothing rocket science in here. It's just a simple definition, a simple logic I need to understand about it. So this combination, this factorial, this is permutation, and now let's get on with it with the questions. Okay, so this is the example right here. This is the example. The example is find the possible number of selection of 3 elements out of 5, A, B, C, D, E. In part 1, I'm making a selection of these of making 3 I'm making a selection of taking 3 elements out of 5. So I will do 5C3, and after doing that, I can see here that this is the answer is 10, which means there are 10 ways to make a selection of 3 out of 5, A, B, C, A, B, D, A, B, E. So all of these 10 selections are different, they are all unique, there is no repetition, and the order does not matter. Alright, but in here, find the number of arrangement of the 3 elements out of 5. After making a selection, I need to know the number of arrangement, so multiply by 3. So I will just do it directly. I can just, even though I can just write it down like 5p3, and I will get the same answer. Okay, I will get the same answer because 5c, it would be 5c3 and then multiply by 3 factorial. So whenever you've been asked to find the number of arrangement of the 3 elements out of 5, it means that first of all you're going to make a selection from it, and after making that selection, after taking out those selected values, these 10 values, and then you need to make an arrangement of each one. Okay, so the first one, multiply by 3 factorial, which means taking out the possibilities of arrangement of the first one, then the second, then the third, and so forth. This is just an example, something that I want you to understand about how this thing works, right? This is how this thing works. This is how you make a selection, and after making that selection, you try to make an arrangement, and this is combination and permutation. Combination is selection, permutation is arrangement. Okay, combination is selection, making a selection from the objects. Okay, and after making the selection, you try to arrange it because the order really matters. This is permutation. Combination is selection. Okay, so let's get on with it. Yeah, this is another example of permutation. Find the number of arrangement of 3 elements. So that's what I've been telling you about, that if I want to make an arrangement of these 3 letters, then I'll just do 3 factorial. 3 factorial means 3 multiplied by 2 multiplied by 1. If I could just say 5 factorial, it means 5 multiplied by 4 multiplied by 3 multiplied by 2. If I could just say 50 factorial, it means 50 multiplied by 49 multiplied by 48 multiplied by 47, and so forth. Okay, so right here I have 3 letters A, B, C, and I want to make an arrangement, so I will just do 3 factorial, and the answer is 6, which means there are 6 ways to make an arrangement. A, B, C, B, A, C, B, C, A, A, C, B, C, A, B, C, B, A. These are the 6 possible arrangement of the letter of these 3 letters A, B, C. Okay, or you can just you can see here the tree diagram, how you can make a selection, how you can make you can find out the arrangement. So these two were the examples to clarify, to understand what is the combination of permutation, and now we need to go through all of these questions. Okay, so there are 3 kinds of question. The first one is a digit. We are dealing with numbers, we are playing with it, and so it has a whole new section of digits. Then the anagrams, which means letters, playing with letters, and then we have gap rule. We'll go through this, don't worry. And then the people. So there are 4 category of these, of doing the question and permutation combination. So let's start with question 1. Question is, find how many different arrangements there are of the 9 letters in the word gold medal. Okay, so it says no restriction on the order. Okay, since there's no restriction, you can easily do permutation. Okay, now in this question, it didn't said anything about making a selection from it. You can just make an assumption. You can assume that it's already been selected. All of these 9 letters have been selected as 9. 9C9 is 1, and then you need to just make an arrangement. Okay, so in order to make an arrangement, you will just do it 9 factorial. Okay, one more thing I want you to understand, and that is repetitions. What happens if there is repetition in the letters? We don't want any repetition. We try to eliminate repetitions in order to make a clear in order to make a clear answer without any repetitions. Okay, so let's go on with it. So I have this is part 1, and this is the word gold medal. You can see here there are 9 letters, and D is repeated 2 times. Okay, and L is also repeated 2 times. Here what I'm going to do, first of all, I'm making a selection, even though there's nothing to be selected from, but I'm just giving you an idea that how things works. Let's say there are 9 letters, and I want to make 9, take all of them, selecting all 9 of them. So I will just do it 9C9, and you can just see it in a calculator. It would be, the value is 1. Okay, then multiply this. Now I want to make an arrangement. I will just do it 9 factorial. Okay, now we need to understand how to deal with repetitions. Whenever there is a repetition, we try to divide it. So 9 factorial upon L is repeated 2 times, so 2 factorial, and D is also repeated 2 times, so multiply by 2 factorial. And the other, there are no more repetitions. So this is how you deal with repetitions. Whenever there's repetition of 3 or 4, you just divide by 3 factorial and multiply, like that. Okay, so yeah, this is the answer. Okay, so moving to part 2. If the two letters D come first and the two letters L come last. Okay, if the two letters D come first and the two letters L come last in this word called medal. Okay, let me do part 2 then. So I'm going to do right here. This is part 2. So, okay, let me just copy this. Okay. So there are 9 letters. It says the two letters D come first. Okay, so I'm going to write down D and D. Then it says, and the two letters L come last. So it comes last then. So D cancel, L cancel, and cancel. And the remainings are, G, O, M, E, A. And there are 5 seats for these 5 letters. So assuming that I've already selected all 5 of them, and after selecting them I need to make an arrangement, because it says different arrangements there of the 9 letters if the 2 letters D and so forth. I need to make an arrangement, so 5 factorial is the answer. So 5 factorial is the answer. Okay, moving to another question. Find how many different arrangements there are of the 4 letters in the word book. Okay, book. Need to make different arrangements, so 4 factorial, since there are 4 letters, and since there's repetition, double O, so I'm going to do upon 2 factorial. This is the answer. We have this question, the digits. Question 1. Find how many numbers between 5000 and 6000 can be formed from the digits 1, 2, 3, 4, 5, and 6. Part 1. If no digits are repeated, which means we can, whenever we try to choose a number, that number will not be used again. What's done is done. Okay, so let's start with part 1. We need to make 4 digits, and the 4 digits must be between 5000 and 6000. So this comes from that 5 must be in here, since we need to make numbers between 5000 and 6000. Okay, so definitely this permutation will also be used here. Now there are 2 ways to do this. The first way is, like, it depends how, in which direction you are trying to think to solve this problem. One direction way, in one way, is you try to see this, that this is one box. Okay, in this box, how many numbers can we select to fill this one? Like, we need to choose at least from we need to take at least one we need to take one number out of 5. 1, 2, 3, 4, 5. So I'm going to say it's 5C1. Okay, then I need to choose this number. In how many ways can I choose one number from the remaining 4 numbers? Because right now I've just taken one number out from 5 numbers, which means the remaining ones would be 4. So 4C1. Then I need to choose any one number from any remaining 3 numbers. So 3C1. Okay, this is the answer. And now I want you to understand what is happening here. Right now, what we did here is, first of all, I just take out 5, because it's in the question. It says between 5000 and 6000, so it's starting with 5 and it's ending with 6000. Okay, so below 6000 and above 5000. Okay, now we have 3 boxes. Starting with the first box, we need to choose any one number out of the remaining 5 numbers. Okay, so I just did 5C1. Now I need to choose another one number from the remaining 4 numbers, because I've already taken one number out, so 5 becomes 4, so 4C1. And then again the total will be reduced to 3. Before it was 5, then it was 4, and now it is 3. Now I'm taking one number out from the remaining 3 numbers, so 3C1. Now what is happening here, like for example, I've just taken any one number out of 5. Okay, so let me just make a diagram. Like for example, 1, 2, 3, 4, 6. Okay, 5C1. So there are 5 ways. Either it is 1 or 2 or 3 or 4 or 6. Then the remaining numbers would be any 4 numbers. If for example I've taken 1, then the remaining will be 2, 3, 4, 6. Okay. Okay, so in the first box, I want to take any one number out of five. So one, either it is 1, 2, 3, 4, 6, any one number out of these five numbers. Then the remaining four numbers. So for example, if I just take in one number, then the remaining will be 2, 3, 4, 6. If I have taken two number, then 2, 3, 4, 6. Oh, sorry, 1, 1, 3, 4, 6. If I have taken three number, then 2, 1. This is 1, 4, 6. And I have taken number 4, then 2, 3, 1, 6. This is 1. And I have taken number 6, then 2, 3, 4, 1. Okay, so this is how you're taking numbers. And then the last one, you have to take any one number out of three numbers, then the remaining will be like this. Okay, so now you can see here that this becomes, you have not only just you just make a selection, but there's also been, you have also made an arrangement. Okay, this looks exactly like I have just told you what this, it's looking like this. Okay, you can do the same thing here, like there are three letters, and I want to know what I can take from here. So remaining three letters, so I'll just do 3C1. Then the remaining two, taking any one from the remaining two letters, then 2C1, and then 1C1. This looks exactly like this. So it's going to be 6 multiplied by 2. Wait, this is 3 multiplied by 2 multiplied by 1, which is 6, which means 6 possible number of arrangement of the three elements by only using the combination. Okay, so this is how you can do it. So this is one way to do this question part 1. This is the answer, or you can just do it the other way, like for example, I can just do it directly. For example, if there are, we need three numbers, right? Numbers from the remaining five numbers. Okay, we need three numbers from the remaining five numbers, so I'll just do it directly. 5C3. End of story. I have made a selection of any three numbers out of five numbers, and then I'm going to make an arrangement of these three numbers once I have selected it. So multiply by 3 factorial. This is the answer, and this is also the answer. You can either do in this way, or you can do in this way, but depending on the answer, depending on the complexity of the answer, you can do either any one of them. Okay. So this was part 1. Now let's do part 2. And in part 2 it says that the repeated digits are allowed. Now what will happen here? Which means that if I'm using 5, then I can use 5 again, because repeated digits are allowed. I can repeat so many times, it doesn't matter, it's been allowed. So I'm going to do, let's start with part 2. Okay, so I need to make 4 digits. Okay. Alright, so here comes 5, but I'm not going to cancel this, no, because it can be repeated, since repeated digits are allowed. Okay, now we have 3 remaining boxes, and in one box, in how many numbers I can, any one number out of 6 remaining numbers, I will do 61. Then again, I can repeat, digits can be repeated, so again 61. Then again, digits can be repeated, so again 61. And this is the answer. Okay, now moving to question 2. Calculate how many different 5-digit numbers can be formed from the 8-digit 1, 3, 4, 5, 6, 7, 8, 9 used without repetition. How many of these 5-digit numbers are? Part 1 is less than 40,000 and part 2 is even numbers. So let's start with part 1. Okay, so 5-digit numbers. 1, 2, 3, 4, 5. And we have this number. Okay, it says from the 8-digit without repetition, how many? Okay, less than 40,000. It must be less than 40,000, and it must be a 5-digit numbers. Okay, since it is less than 40,000, then we can just, it could be like this one, could be one in here, and it could be 3. Okay, it could be 1 and it could be 3. And now the remaining 4 digits we need to select. Okay, it says without any repetition, without repetition. So I'm going to put in here, and then I'm going to put in here. 1 is already taken, and now the remaining are 1, 2, 3, 4, 5, 6, 7. 7 remaining, which means 7C4. And then we have to make a arrangement in order to make so many digit, making so many different 5-digit numbers. So multiply by 4 factorial. Okay, same thing here. 7C4 multiply by 4 factorial. Okay, and then we're going to plus this. So the answer is 7C4 multiply by 4 factorial plus 7C4 multiply by 4 factorial. Okay, so this is the answer. This is part 1. Now let's do part 2. So now in part 2, again, the 5-digit numbers. 1, 2, 3, 4, 5. Again, I'm going to take the numbers. Okay, so it says making an even number. Alright, so this is an even number, even number, even number. So in here it can come 4. Then I'm just going to it could be 6, and it could be 8. Okay, 4, 6, 8, and now the remaining 4. So I'm going to do 7C4 multiply by 4 factorial. Again here 7C4 multiply by 4 factorial, and 7C4 multiply by 4 factorial. Add them up, and this is the answer. Okay, so the question is the digit of the numbers. This can be rearranged to give many different 7-digit numbers. Find how many different 7-digit numbers can be made if there are no restriction on the order of the digits. Okay, so we have this. So let me put it right here. We just need to make an arrangement, since it says how many different 7-digit numbers can be made. There's nothing about selection. These two are repeated, and that's it. 1, 2, 3, 4, 5, 6, 7. 7 factorial upon 2 factorial. This is the answer. Okay, moving to part 2. The digits 1, 3, 7 are next to each other. Alright, they are next to each other. 1, 3, 7 are next to each other. So 1, 3, 7 are next to each other, which means I'm going to put them in a group, and the remainings are 2, 2, 6, 8. They are in different boxes, which means 1, 2, 3, 4, 5. 5 factorial upon, since these two are repeated, 2 factorial. And again, inside the box we also have to make an arrangement. So inside one box, 3 factorial. And this is the answer. And now we're going to move to part 3. These 7-digit numbers are even. Alright, these 7 digits are even. Let's take this again. Okay, so these 7-digit numbers are even. Okay, 1, 2, 3, 4, 5, 6, 7. So what are even numbers? This is even, this is even, this is even, this is even. Okay, let's put here 2. Then again going to okay, and okay, done. This could be 6 and this could be 8 in here. Okay, so there are 1 2 wait 1 2 3 4 5 6 6 numbers. So I'm going to do, okay, since they're already selected, they're already inside the box, so it's going to be 6 factorial in here. Okay, now we have 6. Since we have 6 and wait, let me make it much clearer. Let me put it here and also put it here, and going to put this here. I have already taken 2. The remaining are 1 2 3 6 7 8 6 total, so 6 factorial. Then in here I have taken 6, but these two, they are the 2 repetitions, so in here it's going to be 6 factorial upon 2 factorial. Then in here I have taken 8, again 2 repetitions, so 6 factorial upon 2 factorial. Then we're going to add them up, all of them, like 6 factorial plus 6 factorial upon 2 factorial plus 6 factorial upon 2 factorial, and this is the answer. Okay, we have done these questions. Now moving to another one. Okay, so there are 9 cards are numbered. 3 of the 9 cards are chosen and placed in a line making a 3-digit number. Find how many different numbers can be made in this way if there are no repeated digits. No repeated digits. Okay. So let's see this. Since there are no repeated digits, so what am I going to do? Okay, it says there are no repeated digits and we need to take out 3-digit number. So here's what I'm going to do. I'm going to just take out and put it away these repeated digits, and the remainings will be 1 2 3 4 6. Now I can make a selection from these. So it's going to be 5C3, and it says different number of numbers can be made in this way, which means I'm going to make an arrangement as well, so 3 factorial. Okay, so this is the answer. Now part B. Part B says if the number is between 200 and 300. Okay, so 2, here comes 2, and now I'm going to, so part 2, if the number is between 200 and 300. Okay, so 200 and 300, this is part 2, between 200 and 300, so 2 will be put here. There you go, since we have already used 2. And now in these 2 boxes, so in the first box it could come 1 2 3 4 and 6. Then after getting 1, if I take 1, then I could get 2 3 4 6, which means 4 ways. After getting 2, I could get 1 3 4 6, also 4 ways. And if I get 3, I could get 1 2 and again 3 4 6, 1 2 3 4 6, 1 2 3 4 6, which means 5 ways. If I get 4, then I could get 1 2 3 6, 4 ways. If I get 6, then I could also get 1 2 3 4, again 6, which means 5 ways. So it means that I could get at least, how many ways? I could get at least 22 ways after adding them up. 22 ways, this is the answer. Alright, so I'll get 22 different numbers between 200 and 300. And this way I think permutation also been completed as well, combination. Moving to another question. They are between 100 and 999, in which all 3 digits are different. All 3 digits, each and every 3 digits are different from one to another, which means there's no repetitions in the digit, in the numbers that we are going to make a selection from. So they are, let's start with part 1. So 3 digits. First of all, it says between 100 and 999, 1 to 9. So this is going to be 9C1. Okay. Then since there are total number of 10 numbers, but since we have taken out 1, so it will become 9. at first it says between 1 to 9, so 0 cannot come in this range. That's why we have to take 1 to 9. So 9C1 excluding 0. Then since one number is taken out, it become the total number of 10 become 9, and it includes 0 as well. So again, in this box, this box, it will be 9C1 including 0. Okay, then total number of 9 become 8, so remaining are 8 numbers, so 8C1, and this is the answer. Okay, now part 2, find how many of the numbers part 1 are odd numbers greater than 700. Okay, odd numbers greater than 700, and the digit must be 3. How many of the numbers in part 1 are odd numbers greater than 700? Okay, so let's start at part 2. So again, 3 digits, and it's saying 700 to 900, I guess. 700, 800, 900. Okay, 7 to 9. Okay, now let's take this, put in here, put in here, put in here. Okay, we have already selected 7, or maybe yes, we have already selected 7. Now the remaining 2 numbers. Okay, we need to make odd numbers greater than 700. So odd numbers is 1 3 5 7 9, 1 3 5 7 9, 1 3 5 7 9. All right, so here's what we're going to do. First of all, we're going to take the odd numbers. It could come in here 1 3 5 and 9. So taking any 1 2 3 4, any one number out of 4, we're going to say 4C1. It's going to be 4C1. Then the total number will be reduced to 8, so it's going to be 8C1. Okay, then in here it's going to be same thing here, so it's 5C1 since 1 3 5 7 9, 5C1, then multiplied, and then the remaining will be 8C1. Same thing in here as well, maybe not because it's 9 here. 1 3 5 7, we got 4, so 4C1 multiplied by 8C1. All right, and yeah, this is the answer. And now we're just going to make an addition, add them up, and this is the answer. Okay, moving to the next question. Find how many different numbers can be made from some or all of the digits of the number 1 3 4 5 7 8 9 if all 7 digits are used, the odd digits are all together, and no digits repeated. All right, so all the odd numbers are together. So let me see here. Here's a number. Okay, find how many different numbers can be made from some or all of the digits of the numbers. If all 7 digits are used, the odd digits are together, no digits repeated. Alright, so all digits number are together. 5, 7, 9, they are all together. Then what we have left here is 4 and then 8 different boxes. It's going to be 3 factorial, and inside the boxes I also have to make an arrangement, so 5 factorial. Okay, so this is the answer. Okay, now moving to part 2. Alright, in the part 2 it says the numbers made are even numbers between 3000 and 5000 and no digits are repeated. So 3000 and 5000, which means 4 digits. 3000 and 5000, so okay, it's also telling that it must be an even number. Okay, 3000 and 5000 can come here. 3 4, maybe not 5. Okay, now we're going to see here that what will happen. We have already used 3, now remaining. Okay, we need to know the even numbers. 4 is even, 8 is even, 4, 8 are both even numbers. So first of all, we're going to take out the even number, so it's going to be a 2c1, then multiply by 1 2 3 4 5 5c2 is going to be the, write it down like, okay, let me make it let me copy this. I've just noticed it right now. Okay, you could either write it down like okay, so there were 7 numbers, we have taken 3 out, so 6. Then we need to find we need to take any to 1 from the 2 remaining even numbers. So 4 and 8 are 2 total numbers, 2c1, which means we have taken 1 out, so the remaining would be 5. Then we could write down like 5c1 and then multiply by 4c1, and then same thing in 4. In here is, okay, so we have already taken 4, we have to take 8 as an even number, the remaining would be 5c1 and then multiply by 4c1, just like we have talked about in here, right? Same thing in here, same thing in here, we are doing this in here as well. All right, so doing in this way, we have already made automatically, if arrangement has been made and we got the answer. Or we could write it down like what I'm going to show you right now. Okay, so this is 2c1, and then I could just do it directly like 5c2. Okay, but then I also have to make an arrangement, so I'll do 2 factorial. Similarly, same thing here, it's going to be 5c2 and then multiply by 2 factorial. So in conclusion, anything that whenever we try to make a selection, if we try to, for example, there are 4 or 5 boxes, and each boxes we have to take numbers, right? And I could just do, for example, there are 7 numbers and there are 5 boxes, and I want to make an arrangement as well. So either I could do it directly like 7c5 and then make an arrangement like 5 factorial, which we can also write it down like 7p5, or we can just do it individually, like for example 7c1, and there's no repetitions, there's no repetitions in repeated digits allowed, repeated digits are not allowed. So 7c1, then we could do 6c1, then 5c1, then 4c1, then 3c1. We could do it like this as well, and both the answers are same and both the answers are correct, but the method is different. So depending on the complexity of the question, we will decide which method to choose in order to make in order to give the solution to the problem. Okay, so either one of them is absolutely correct, you can do either one of them. Okay, even I would prefer both of them, but depending on the complexity of the question, you will decide which one is more suitable. All right, so either one is correct. So this is the answer. Part 2 is done, part 1 is also done, and part 3, what is part 3? Let's figure it out. It says less than 1000 and digits can be repeated. Since it says less than 1000, which means this come 5 5 5 and digits can be repeated, so 7c1 multiply by 7c1, here 7c1, and there you go. So we got 7 7 49, 7c1 multiply by 7c1 plus 7c1 plus 1. This is the answer. Okay, yeah, so this is done. Okay, so now we're going to start with the anagrams with letters. Question 1: a selection of 3 letters from a selection of 3 letters from the 8 letters of the word collider is made. How many different selection of 3 letters can be made if there are no restrictions? Okay, fine. Okay, so it says how many different selections of 3 letters can be made if there are no restrictions. Okay, if there are no restrictions, and we need to make 3 letters, selection of 3 letters. First of all, we're going to see here that there are repetitions. So first of all, we're going to deal with repetitions. Let's suppose that there are no L's, and we are making the selection 1 2 3 4 5 6. So 6c3. Okay, now there's 1 L, So it's going to be 62, and now there are two L's, so it's going to be 61. Okay, so yes, this is the answer. Now we're going to add them up. It's going to be the answer. This is part 1. And in part 2 it says how many different selection of 3 letters can be made if there is exactly 1 L. If there is exactly 1 L, then I suppose if there is exactly 1 L, then this is the answer. 62 is the answer. So part 2 is 62. Okay, now moving to the next question. A selection of 3 letters from the 8 letters of the word corridor is made. Same. How many different selection of 3 letters can be made if there are no restrictions? I think I've done this already. Okay. Seems like I've already done it. Okay. So this is being repeated actually. Moving to another question. 4 of the 8 letters of the word Tanzania are selected. How many possible selection contain exactly 1 N and there's question mark, which means 1. Okay, let's just do it. So this is the word Tanzania, and there are 3 letters, and also there are 2 N. Okay, exactly 1 N. So okay, so it must have exactly 1 N. But what about other repeated letters like A? So let's do this. 4 of the 8 letters, which means we need to make 4 letters. Okay, so this is the 4 letters. So exactly 1 N, which means N is already taken and some of them are out. Okay, and now let's suppose there is no A and the rest are T, Z, I. Okay, so that's the first. It's going to be, I think so, and I think that's going to be 1 actually. So 3C3. Then the next one, exactly 1N, and there is 1A, so let's just take it. Now 3C2. Then exactly 1N, and there are 2A. Okay, so there are 2A, and it's going to be 3C1. Then N and all A, so it's going to be 1. Then we're going to add them all up, and this is the answer. Okay, yep, this is the answer. Now let's move on to the next questions of this. This is the last question of anagram. Question 3, I think. Yeah. 5 letters are chosen from the 9 letters of the word 17. Find the number of possible selections which contain at least 2 E's. Okay. So let's just do it. Oh, what's happening here? Okay, I think I haven't taken it really beautifully, so I'm just going to do it. Let's do this again. I think I've got it. Okay, so 5 letters. Let's do this. Taking 5 letters from this word. There are repetitions. Okay. It says at least 2 E. It must have at least 2 E's. So, at least 2 E and no N's. Okay. And those letters which have no repetition, SVT. Okay, so it's going to be 3C3. Then what will happen? E, and there is 1 N, so it's going to be then 3C2. Then there are 2 N, total are 2 exactly. Okay, and 3C1. Then it says that it must have at least 2 E's, but we can have more than 2. We can have 3 E's, we can have 4 E's, but I think there are total 4 E's. But let's start with 3 E's. You can have 3 E's with no N's. Okay, so it's going to be 3C2 again. Yep. Then there's 1 N, so 3C1. Then 3E and 2N. this is going to be 1. And now we have 4e with no n, so it's going to be 3c1. And then we can have last line, and this is 1. So I think this is correct. Yeah, let me confirm this from my marking schemes. So 3c3 plus 3c2 plus 3c1 plus 3c2, 3c3, 3c2, 3c1, 3c2, 3c1, and 1, take just 1, and then another, okay, 3c1 again, and 1. Okay, so it's going to be 1 plus 3 plus 3 plus 3 plus 3 plus 1 plus 3 plus 1, and then it's going to be 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And yes, that's right, this is correct. The answer is correct. Okay, the anagram part is done. Then we will move on to, let's move on to gap rule. So let's start with the gap rule. Question 1. Find the number of ways the 9 letters of the word 17 can be arranged in each of the following cases. No E is next to another E. Okay. No E is next to another E. There are 4 E's, and we have S, V, N, T, N. So now we're going to use the gap rule, since it says no E is next to another E, which means the two E's, any of the E's must not be in contact to another E. Okay, so we are going to separate them. Like, it's the same thing when there are two siblings, they are fighting to one another and they don't want to see their faces. They don't want to see their faces for one day. So they try to have some space for themselves. They go in different room and they lock themselves up. Yeah. Similarly, the same thing. Like a child is having a fight with his parent, and the child just lock himself in a room. Or two friends don't want to see each other's faces. They don't want to be around. They want to be alone. Same thing here. We just give a gap. Okay. So this is gap rule. We're going to see how this works. So let's start giving gaps. V, N, T, N, and there you go. There are gaps. 1, 2, 3, 4, 5, 6. 6 gaps, and we have 4 E's. So first of all, we're going to choose any 4 gaps out of 6. 64. Okay, and then after taking those gaps, you're going to make an arrangement of these 4 E's, but since they are all similar, there's repetition, so divide by 4, which cancels out, and then we're going to shuffle these letters as well. So 5 factorial upon 2 factorial, because there are 2 and repetitions, and so I think this is the answer. Yes, definitely, this is the answer. I've checked it. Okay, another question. The 11 letters of the word remembrance are arranged in a line. Find the number of different arrangement which do not have all 4 vowels next to each other, which means, so this type of question is very, very tricky. The reason, guys, this is not just another simple question. I have put this very tricky question in my video because this type of question was very tricky for me, and I think it will be hard for you to solve it if you don't understand if you don't understand how to solve this. So look at the words that it has given, which do not have all. It didn't say which do not have 4 vowels next to each other. It says which do not have all 4 vowels. So there is a difference. Since it's saying that it do not have all 4 vowels, it means that these 4 vowels must not be next to each other. But it could be in this possible scenario that the 2 vowels could be next to each other and the other are not next to each other, or they are all separately. But it says that all together they must not be next to one another all together. Okay. Yeah, this is what it means. Do not have all 4 vowels next to each other. But it didn't say about this or this. It can happen. They can be 2 vowels can be together and the other cannot. two vowels and two vowels in group together, they can, but all four vowels must not next to each other. That's what it's saying. These words, this what the question is talking about. Okay, so this one is very tricky, and in order to solve this, we're going to use this formula, which is the second method, and the gap rule is total minus together is equals to non-together. Okay, so we're going to use this. So total minus together. Let's supposing that all these four vowels are next to each other, and then we're going to subtract it from the total, which and by means and total means having no restrictions. Okay, it's a sum of it's a sum of having all together and having not all together, so it's a total. Okay, so 11 letters. Let me just take it out. Okay, so E, E, and E, and M, okay, and this R, and then there is, and that's it. Okay, so 11 factorial upon how many E's? There are 3 E's, so 3 factorial multiply by, there are 2 M, so 2 factorial multiply by 2 factorial 3 E's and 2 R. Okay, so there are 2 R and 2 factorial, then minus, and now we are assuming that all these four vowels are next to each other. So which one are the vowels? E is a vowel, E is a vowel, A is a vowel, E is a vowel. So there are actually 4 vowels. Okay, which means E, E, A, E, they are all together, and the rest of them are R, M, B, R, N, C. Okay, 1 2 3 4 5 6 7 8 8 factorial, there are 8 factorial upon 2 factorial multiply by 2 factorial, and yeah, and inside the box 4 factorials, and inside there are 3 E's, so upon 3 factorial, and this is what it is. We're going to put in here. There you have it. We have this answer, and so if I just use a calculator, then I will get 1663200 minus 40320, and the answer is 1622880. This is the answer. It's confirmed. Okay, moving to the next question. Find the number of different ways in which the 9 letters of the word green gauge, okay, green gauge, can be arranged if exactly 2 of the G's are next to each other. Exactly 2. Okay, so this is very simple question. We have 3 G's, 2 E's, and we have 3 E's. So we have 3 G's and we have 3 E. Okay, and saying if exactly 2 of the G's are next to each other, so we're going to put 2 G's in a box, and another G's one box, and the rest will be, and then we're going to use the gap rule. So R, E, E, N, E, A, E. Okay, now 1 2 3 4 5 6 7 gap 7 C 3. Then we're going to do, yeah, so it's 7C, wait, 7C2, 1 2 3 4 5 6 7 7C2. They will shuffle, so multiply by 2 factorial, and then all these will shuffle as well. So 1 2 3 4 5 6, so multiply by 6 factorial upon 3 factorial, and this is the answer. Okay, so let's move on to the next questions. Okay, question: the 4 tenors and 4 basses in the group stand in a single line with all the tenors next to each other and all the basses next to each other. How many possible arrangements are there if 3 of the tenors refuse to stand next to any of the basses? So there are 4 tenor and 4 basses. So T, 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 P, B, B, P. Okay, and it says that all the tenors next, okay, if 3 of the tenors refuse to stand next to any of the bases, so which means 3 of them are in one box and they don't want to see each other faces of the to any of the bases. Okay, which means that they are also in one box. Okay, so they can shuffle from their places, so this is 2 factorial. Also inside one box they can shuffle, so 3 factorial. And the bases they can shuffle, so 4 factorial. So this is the answer. Okay, another question. 9 cards, each of a different color, are to be arranged in a line. How many of the arrangement of 3 cards do not have the pink card next to the green card? Okay, so there are 9 cards and we have to make an arrangement after selecting any 3 cards from 9. Okay, so here's what you're going to do. Okay, do not have the pink card next to the green card. Okay, do not have the green card next to the green card. Pink card next to the green card. So let's suppose that pink is out but green is in. So here you go, G, and I'm going to choose 7C2, then multiply by 3 factorial. Okay, then again pink in, green out. So this is pink, and again 7C2 multiply by 3 factorial, and now both of them are out, so 7C2 multiply by 3 factorial, 7C3 multiply by 3 factorial. Alright, so I think this is the answer. And wait, both of them out, pink out, green out. But it could also be possible that both of them are here and here, and this is going to be 7C1 and then multiply by 2 factorial, since they can shuffle from their places. Okay, and now we are going to, and yeah, this is the answer. We're going to add, we are going to add all of them, plus 1 2 3 4, and this is the answer. Okay, the last question of gap rule. The back row of cinema has 12 seats, all of which are empty. A group of 8 people, including Mary and Francis, sit in a row. Find the number of different ways they consist in these 12 seats if there are no restrictions. Okay, if there are no restrictions, there are 12 seats and there are 8 people, and we need to find the number of different ways they can consist these, which means there will be arrangement as well. So 12C8 multiply by 8 factorial. This is part 1. Part 2 is Mary and Francis do not sit in seats which are next to each other. Okay. So Mary and Francis do not sit in seats which are next to each other. We can use the second method to resolve this because this is definitely very complicated. Let's suppose that Mary and Francis are together, right? So here's what we're going to do. Total minus together is equals to non-together. This is total is C12C8 multiply by 8 factorial, and minus would be taking Mary and Francis as together, and they are, after making a selection, let's say 12C7. Since Mary and Francis are together, there are 8 people, right? P. Mary and Francis are together, best friend, couples. Okay, and now we are going to take seeds. So 12C7 multiply by 7 factorial multiply by 2 factorial. Okay, so this is how it's going to be, and the answer is, after using the calculator, the answer is this. And yes, this is the answer, correct. Okay, now we have this, the people. We have these type of questions. This is the last part. A committee of 5 people is to be chosen from 6 men and 4 women. In how many ways can this be done? If there must be 3 men and 2 women on the committee. Okay. So this is part 1 and it says man and woman, and man has there are 6 and woman there are 4. Okay. It says it must be 3 men and 2 women. Okay. 6c3 and 4c2 multiply. Okay. And how many ways can is to be chosen? Okay, so we just need to make a selection, and so this is the answer. Okay, this is the answer of part 1. Okay, now the next part 2. If there must be more men than women on the committee. If there must be more men than women on the committee. Okay, more men than women on the committee, and we need to choose 5 people. If there must be more men than women on the committee. Okay, and there must be 5 people needed for this. Five people needed. Okay, more men than women on the committee. So let's start with more men than women, huh? So 6c5 4c0, selecting all 5 men and 0 women. Then we could just do 6c4. Okay, yeah, 6c4 4c1, 6c3 4c2, and that's it. Plus. Okay, add them up, multiply them, add them up, and you got the answer. Now the third part. If there must be 3 men and 2 women, there must be 3 men and 2 women, and one particular man refuses to be on the committee with one particular woman refuses to be on the committee with one particular man. Okay, let's see this. So it's saying that we need there must be 3 men and 2 women. Okay, let's suppose that one man is out, one man out, one woman in. Since one man is out, then we could just 5c3 multiply by 4. I could say 3. It's going to be 3c1, since that woman has already been selected. Okay, then it could be one man in, one woman out. That's going to be, if one man is already in, then 5c2, since one is already selected, and one woman is already out, so it's going to be 3c2. Okay, because one man is when one woman is out. And the last part, both out, so it's going to be 5c3, and it's going to be 3c2. And now you just add them up, add them, and this is the answer. Okay, so we have this question. Question is, a school club has members from 3 different year groups: year 1, year 2, year 3. These are 7 members from year 1, 2 members from year 2, and 2 members from year 3. 5 members of the club are selected. Find the number of possible selections that include at least 1 member from each year group. Okay, so year 1, year 2, year 3. Year 1 has at least 7 members, at least 2 members, at least 2 members. We need 5. We need 5 members, and they all must have at least 1. At least 1. Okay, they must have at least 1, and so Yeah. Now let's make a selection. Seeing that they are selected, we need to make possible selections. So in here we can select 7c3 multiplied by 2c1 multiplied by 2c1, or we can also make a selection in this way: 2 multiplied by 7 2c1 multiplied by 2c2, or in this way 7c2 multiplied by 2c2 multiplied by 2c1, or in this way 7c1 multiplied by 2c2 multiplied by 2c2. And that's it. There you go, we have the answer. Just add them up and this is your answer. This one is done. Now moving to another question. A cricket team of 11 players is to be chosen from 21 players, consisting of 10 batsmen, 9 bowlers, 2 wicket keepers. The team must include at least 5 batsmen, at least 4 bowlers, and at least 1 wicket keeper. Find the number of different ways in which the team can be chosen. Okay. Then let's see. So we have batsmen, bowlers, and wicket keepers. Okay. Batsmen, bowlers, wicket keepers. Okay. Okay, so batsmen have 10, bowlers have 9, and wicket keepers 2. And this is 2. Okay. Now, yeah, 11 player is to be chosen from 21 players. 11 select 11 players. Okay. The batsmen must have at least 5. Okay. And bowler must be at least 4. Okay. And wicket keepers must be at least 1. Okay. Must be at least 1. Now let's make a selection. Find the number of different ways in which the team can be chosen. Okay, if I make 5, if I make 10c5, and here I choose 9c5, and here 2c1. Okay. I could also choose in this way, like 10c5, 9c4, 2c2, or I could choose in this way, 10c. Okay. I can do in this way, 10c6, 9c4, 2c1. Okay, and let's see if there are any more possibilities. So we have 5, 4, and 2, then 5, 5, 1, and 6, 4, 1. Okay, so there are no more possibilities, and I think this is the answer. Plus, this is the answer for part 1. Okay, so part 1 is done, and now let's move on to part 2. Let's start with here. Part 2 is saying that each player in the team is given a present. The present consists of 5 identical pens, 4 identical diaries, and 2 identical notebooks. Find the number of different arrangement of the present if they are all displayed in a row. That's too easy for me. So there are 5, 4, and 2. Okay. 5 identical pen, 4 identical diaries, and 2 identical notebooks. So it's going to be 5, 9, 10, 11 factorial upon 5 factorial multiplied by 4 factorial multiplied by 2 factorial. This is the answer. Okay, it's done. Now let's see part 3. 10 of these 11 presents are chosen and arranged in a row, which means they are already been chosen, and what we needed to do is we need to just make a different arrangement that are, we need to find the number of different arrangement that are possible. Okay, so I think it's pretty much easy for us since we have it's already chosen 10 of these 11 present and arranged in a row. Let's suppose we have neglect one pen, and now we need to find the number of arrangements. So it's going to be 10 factorial upon 4 factorial 4 factorial multiplied by 4 factorial multiplied by 2 factorial. Then we could also have the possibility of neglecting one diary. Same thing here, 10 factorial. Okay, so it's going to be 5 factorial multiplied by 3 factorial multiplied by 2 factorial. Now we could neglect and one notebook. There you go. 10 factorial, 5 factorial, 4 factorial, and 1 factorial, or maybe not. Okay, so this is the answer. Add them up and you get the answer. Alright, so that's how we do it. So this question is done. Now moving to another one. Okay, so we have this question. A builder is planning to build 12 houses along one side of a road. He will build 2 houses in style A, 2 houses in style B, 3 houses in style C, 4 houses in style D, 1 house in style E. Okay, so we have here A, B, C, D, E. Okay. Style A have 2, B have 2, 3 has C has 3, house D has style D 4, and E has 1. Okay. Okay, 4 of the 12 houses will be selected for a survey. Exactly 1 house must be in style B and exactly 1 house in style C. Find the number of ways in which the 4 house can be selected. It's talking about selection, so we need to choose 4 houses, and exactly 1 house in style B and exactly 1 house in style C. Style B, let's suppose 2C1, and style C 3C1, and the remaining we can just choose from. So this is 2. Okay, first thing here that we are already done with this. 2, 4, 6, 7. So it's going to be 7C2 for the remaining 2 seats. And I think, and definitely yes, this is the answer. Okay, now we have this. Pegs are to be placed in the 4 holes. The 4 holes are as follows, like this. Wait. There you go. Beautiful diagram. There you go. Bags are to be placed in the 4 holes. Barrel has 12 bags, consist of 2 red, 2 blue, 2 green, 2 orange, 2 yellow, and 2 black bags. Calculate how many different arrangement of colored bags in the 4 holes barrel can make using 4 different colors. Okay. So we have red. How many? What do we have here? Red, blue, green, orange, yellow, and black. They all have 2. It seems 4 different colors, which means we're going to neglect those which are repeated. So I'm just going to say, yeah, it's going to be like this. We're going to take 6, red, blue, green, or orange, yellow, black. 6, it becomes 6, neglecting any other packs which are identical. So 6c4, and then it says different arrangement, so multiply by 4 factorial. Okay, this is part 1. Part 2 is saying 3 different colors. Okay, so we are going to choose any 3 different colors from the remaining 6. Okay, if I choose like this, so 6c3, choosing 3 different colors from 6 unique colors. And after choosing them, and after choosing them, we really have to make an assumption that, you know, we need to put the specs in these 4 holes. So like for example, if you have red, green and blue, and let's suppose you have chosen these unique colors, these are 3 different colors, and expecting like you have 2 red identicals, 1 green and 1 black. It could also be possible that we have 1 red and 2 identical green and 1 black, and so forth. You make it in this way. Then okay, so you make out in this way. So you can just say there are 3 possible ways. Okay, so multiply by 3, and then after getting in one of these ways, you're going to arrange them. So again, it's going to be 4 factorial upon 2 factorial. Okay, so this is the answer for this. Now any of our 12 packs. Okay, there are 4 holes. In part 3 it says any of our 12 packs. Okay, we know that there are 4 holes to be put in it, and she said that any of our 12 packs, which means it could have 4 different colors, could have a possibility of 4 different colors, 3 different colors, or 2 different colors, which means for example red, green, blue, yellow. If there are 4 different colors, then 1 for each. If there are 3 different colors, then you can see that 2 1 1. If they have 2 different colors, then red, green, 2 2. And what happens if they have 1 different color? That's not possible. Okay, because the maximum number of packs for each color are 2. 2 are the maximum. That's why we already know 4 3. We need to find out about 2. So in here, making a selection of 2 different colors, so 6c2 multiply by, and after selecting it, we're going to arrange it, do some arrangement. So it's going to be 4 factorial upon 2 factorial multiply by 2 factorial. So this is the answer for this one. And then we're going to add all of them. We're going to add part 1, part 2 and this one. Okay, and this is the answer, and I think that we are done. This is the end of permutation and combination. So congratulations, we have done it. And now let's move on to the other chapters, and I'll see you guys in the next video. Thank you.